Good evening, all of you. So now we are conducting English medium revision for the business mathematics and statistics subject. So we hope that this will be very beneficial for all of you for your AAT examination. So it's my honor to invite Mr. Kasun Rodrigo to conduct the business mathematics and statistics English medium seminar. Over to you, sir.
Good evening, Buta. Today's in today's session, we are going to discuss uh, an important lesson in your syllabus, which is probability. Okay. Uh, so uh, I'll be doing some theoretical parts. I'm going to like give you an idea about what you have learned, and I'm going to do some calculations with you as well. I'm going to do some papers with you. Okay. So be ready for that as well, and keep your calculator with you, and as well as the Z table. You know what it is, the Z table. You want to have that, those two. Okay. So when we are moving to a probability part, okay, probability part. So what is probability? Do you know what it is? What is probability? So probability is the likelihood of an event. Okay. The like it's like this. The chance of happening. Okay. So Pute, let's say like this. I'll give you some examples. Okay. Uh, one example. We have a match. Sri Lanka having match with India. Okay. And we say, okay, the winning probability is 67%. Winning probability, which means we have a chance of, a 67% of chance to win this match. Okay. Winning probability. Next, I can say, okay, there's a chance of having rain tomorrow. The chance is around 40%. Okay. Again, okay. What we say is, okay, we have a chance of having rain. Okay, chance, the probability. Okay, probability of happening. Okay, so that is about probability. I mean, the idea about probability. Okay, so under probability, we are talking about different incidents. Okay, everything is based on incidents. Under probability, everything is based on incidents. So when you are learning this lesson, okay, when you are learning this lesson, you will hear different incidents. Okay, incidents, and we say events. Okay, we say it as events. Okay, events. Okay, when it comes to events, we can divide it into three. What are those three? First one is impossible. Oh, wait. My handwriting is not that good, huh? Okay, I'll write it impossible. Okay, these events will never happen. Okay, අපි අර සිංහලෙන් කියනවනේ වෙන්නේ නැහැ. Okay, so as an example, the sun will rise from west on tomorrow morning. It will never happen. Okay, කවදාකවත් ඉර බස්නාහිරින් පායන්නේ නෑ පුතේ. Okay, so those events, there is no chance of happening. Okay, no chance. Okay, whatever happens, these events will never happen. Okay, මොනවා වුණත් පුතේ මේ events වෙන්නේ නැහැ. So if we can assign a probability, I mean assign a value for probability of these events, it is zero. Okay. Next we have definitely these events will happen. Okay. Definitely it will happen. As I said earlier, the sun will rise from east. Okay, on tomorrow morning. You know, whatever happens, අපි සිංහලෙන් කියනවානේ බඩු ෂුවර් මේක නම් වෙනවා. Okay. So if we assign a value for the probability of these events, it's 1. Okay, 1. Then the next one, we have random events. Random events. Okay. All the other events are comes under random events. Okay, random events. If we assign a probability for these random events, it should be a value in between 0 and 1. Every other event than impossible and the other events. Okay, I'll give you an example. Kusal Mendes scoring a century in the next match. A random event. It can be happen or on the other side as well. There is a, probability for happening and as well for the other side. And I say, okay, having rain tomorrow. Okay, chance of happening and the other side as well. Okay, so every other event, okay, comes under random events. Okay, so Pute, as I said, if you assign a value for the random events, it should be a value in between 0 and 1. Okay, 0 and 1. But when we are writing down the probability for these random events, we are writing down it as a fraction. Fraction. Okay. Why it is a fraction? So it is the standard way that we are writing the probability. Standard way. Okay. We can write down probability in several ways. Either a decimal number or a percentage. Okay. But the standard method is writing down it as a fraction. Okay. Fraction. That's it. So I will show you how to find out the simple probability of a random event. Okay. So I will write down an event here. Okay. Getting heads. Wait. Okay. Heads from a coin. Okay. Heads. Now, when you are tossing a coin, how many results or outcomes are there by tossing a coin? You can have heads or tails. Okay. So two outcomes are there. Out of two outcomes, how many heads are there? Only one. Okay, only one. So the simple probability of this event is 1 upon 2, which means you have to write down the total number of outputs in the denominator and the total number of outputs under that specific event. Okay. So that's how you are going to write down the probability. I'll give you another event. Having an even number from a dice. Having an even number from a dice. How many even numbers are there in a dice? How many even numbers are there? Okay. How many even numbers are there in a dice? Can anyone tell me? How many even numbers are there? 3. Very good. 3. So when we are throwing a dice, the total number of outputs here 6. For the event, the specific events, the number of outcomes is 3. Okay. So the simple probability is 3 upon 6. So you can further simplify it as 1 upon 2. Okay. That's it. That's how we are going to find out simple probability. Okay. Got it? So Pute, next, like when we are uh, representing these events, we have like different options. Okay, when we are representing the outcomes of the events, we have different options. First one is you can write down as the sample space. Likewise, under the brackets. Next, you can write it down as scatter plot diagrams. Draw, you can draw it likewise. Okay. Next, you can use tree diagrams. Likewise. Okay. So there are different ways. Okay. Like I'm just touching these areas like to give you an idea and to recall your memory on what you have learned during past 6 months. Okay. Uh, Next one. So since we are talking about incidents or events under these lessons, there are different events. Huh? Okay. So I'll teach you one by one separately and like clearly. So if you don't get anything, feel free to send a message to the chat box. Huh? Harid Pute. So next one, we have simple events and we have compound events. Simple events and compound events. Okay. So what is simple event? Okay. So simple under simple events, the number of outcomes is 1. Okay. It has only one outcome. Let's say having head from a coin. Having heads, only one outcome. Okay. So we are having heads. When it comes to a compound interest, I'm throwing a dice. So we have 6 outcomes. Okay. Throwing a dice. I'm not specifying what is the number. Okay. So compound under compound events, we have many occurrings. I mean many outcomes, but not in simple events. Okay. Okay. So that is the difference between simple and compound events. Okay. Now I'm coming to the most important part of this lesson, Puti. Okay. So listen very carefully. Okay. I'm going to teach you the rules of probability. Okay. There are different rules. I'm going to teach you all those rules. So listen very carefully. If you have take a paper and write these rules, okay, in your paper as well. Okay. Okay. Now, first one. First one. Okay. O rule. O rule. So I'm going to ask you a question. Okay. Now let's say I'm teaching to a class and I say, okay, Amal o Kamal. Okay, I'm again saying Amal o Kamal should be there in the class on tomorrow morning at 7 a.m. Amal o Kamal should come. I mean, Amal o Kamal should be there in the classroom at 7 a.m. on tomorrow morning. Okay. So who should come? Amal or Kamal or both or who? Can anyone send me the answer? Okay. Others? Give it a try, yeah? I want to check whether you got the thing. Whatever the answer, just send me the answer because I can have an idea. I'm asking again. Amal or Kamal should be there in the classroom at 7 a.m. on tomorrow morning. Who should come? Amal, Kamal, both, or one of them? Okay. Okay. I don't mind whether it's Amal or Kamal. I don't mind. Oh, I don't mind both. Okay. So that is the missing part of your answers. Okay. I don't mind whether it is Amal or Kamal. Amal lavat kamak nahe, Kamal lavat kamak nahe. Or both of them. I don't mind it. But there should be at least one. At least one. Okay. At least one. So that is the condition. At least one should be there. I don't mind it's Kamal or Amal or both of them. Okay. So O rule, under O rule, okay, at least one should be there. One should be there. Okay. This is Amal. Amal can come. This is Kamal. He also can come. And also both of them. I don't mind. Okay. So this is union. This is called union. Okay. Union of A and B. Okay. Got it? Clear? Next. Next rule. Second one. And. And. Now again I'm asking. Amal and Kamal should be there in the classroom at 7 a.m. on tomorrow morning. Who should come now? Amal, Kamal, both of them, or one of them, or at least one? Okay, very good. Both, both of them. Amal and Kamal should come. Amal and Kamal. ඔය දෙන්නම එන්න. Okay. So N means the intersection or both of them. This is the condition. Okay. A intersection B. Okay. That's it. Now I'm moving to the third one. Okay. We have complement. Complement of the event. Now I say, okay, the event is Andrew Kumara Disanayaka will be in the election. So before the election, we say, okay, Andrew Kumara Disanayaka will win the election. Okay. So that is the event. Now what is the complement of the event? Complement. Okay. So complement is the other side of the event. Okay. Other side of the event. What is the other side? Andrew Kumara Disanayaka will defeat the election. Event is Andrew Kumara Disanayaka will win the election. So complement is Anuru Kumar Disanayak will defeat the election. Okay. So if this is the event, here is the complement. The area that is not belongs to the event. Okay. So when we are writing down the complement, we write down the event and put a dash here. This is the symbol of the complement. I mean, symbol of the event, complement of the event A. When you put a dash, it says complement of event A. Okay. Complement of event A. Okay. So we have learned now 3 rules. Okay. I'm going to teach you another one. Okay. Now we have learned this one. A intersection B. We have learned that one. And we have learned this one as well. So we have learned this one, intersection B, and we have learned this one. Okay. Now, when I'm drawing this one, so you know A union B means the whole area. Okay. So first of all, you are coloring this one. Okay. Then you are coloring this one. So what happens? When you are coloring both events one by one, you color the intersection part twice. Okay, am I correct? You have colored this intersection part twice. When you are coloring A, you color the intersection part. When you are coloring B, you again color this one. Okay, so A union B, when you're writing A plus B, you have to subtract one intersection part. Why? You have added it twice. Okay, so you have to subtract one part. So if you want to find out the probability of A union B, you have to find out the probability of event A, add the probability to the event B, and subtract this one. So this is the O rule. Okay, O rule. Got it? Okay, Pute. Now, next we have this one. Mutually exclusive events. So mutually exclusive events, Pute, they don't have an intersection. Okay. They can't come to a common ground. Okay. Because they don't have an intersection. Okay. They discuss throughout the day, but can't come to a conclusion. Okay. They are not in a common ground. They don't have an intersection. Okay. They can't see anything that they can agree. Okay. Because they don't have an intersection. Okay. So events which don't have an intersection are called mutually exclusive events. Mutually exclusive events. Okay. I'll give you an example. I'm throwing a dice. Okay. And I'm tossing a coin. Throwing a dice will give 1, 2, 3, 4, 5, 6. Tossing a coin will give heads or tails. Okay. By the way, they don't have an intersection. Okay. No intersection. Okay. Now, if you want to find out A probability of A union B of this one, it is very simple. Add the probability of A to probability of B. We don't have minus this one because it is equal to 0. So I don't need to write it down. Okay, since we don't have an intersection, I don't need to write it down. So for mutually exclusive events, keep this in your mind. Mutually exclusive events are events which don't have an intersection. Okay. Okay. Next one. We have events. Again, we have independent events. Next one, we have dependent events. What are called independent events? Independent events. Say we have two events, A and B. A and B. Okay. So independent, if A and B are independent events, okay, the occurring of A will not affect the occurring of B. The results of A will not affect the occurring of B or the results of B. Okay, I'll give you an example. Kusal Mendes scoring a century. I'm having a bath. There is no, I mean, like uh, whether the Kusal Mendes scores a century or not, I don't mind. Okay, that event can't like affect uh, my decisions. Okay, so those are independent events. Throwing a dice, okay, and having three from the dice, and tossing a coin and having head, can the number three can affect having heads from the coin? No. Independent events, okay, results of one event will not affects the results of the other event. Okay, those are called pute independent events. Now what is called dependent events? Well, the other sides. Okay, again we have A and B, but the results of A will affect the results of B. Okay, results of A will affect results of B. So I'll give you an example. Driving very fast, okay, driving very fast and having an accident. Okay, driving very fast and having an accident. Okay, there's a chance. Okay, when you are driving very fast, there is a probability of having an accident. Okay, dependent events. Okay, so in our childhood, I mean, I'm talking about late 90s. Okay, 90s and in after that after that decade. Okay, so what we saw was like when Sanat Jayasuri is like when he is like scoring a half century or a century, what we see is okay, there's a probability of winning the match. Okay, if Sanat Jayasuri scores a 50 or 100, okay, we have a high chance of winning the match. Okay, so what we can see those events, like we saw these events as dependent events. Why? Scoring a 50 or 100 by Sanat Jayasuriya will definitely affect the results of the match. But we see it as it is. Okay. So those are dependent events. If results of one event affect the results of the other event, okay, those are called dependent events. Dependent events. Okay. So keep that thing in your mind. So when we are doing calculations, you will go through different dependent events. Okay. Next we have conditional probability. Conditional probability. Okay. Okay, I will say, okay, I'll have two burgers. Okay. When I have two burgers, the chance of having, I feel sleepy is 70%. I have two burgers. Okay, I'm going to have two burgers. Okay, when I had two burgers, the chance of feeling sleepy is 70%. Conditional probability. There is a condition. If I have two burgers, that is the condition. I will feel sleepy. Okay. If I have two burgers, I will feel sleepy. Condition. There is a condition. Okay. Now, if it is conditional probability, we write it down as like this. Condition is there, event is there. We write it down as um, A intersection B divided by this one. If you write it down like this, always you divide it by the probability of the from this event. Okay, this is called conditional probability. Okay, conditions. There are conditions, which means again dependent events are dependent events, because I'm having two burgers. Okay, and I feel sleepy. Okay, having two burgers affects the next one. Okay, so that is about probability. Okay, probability. uh Next we have, okay, after probability we have probability distributions. Okay, Pute? Probability distribution. So probability distribution, basically we name it as normal distribution. Normal distribution. Okay, normal distribution. So you know this curve. Okay, this is a bell-shaped curve. Okay, this is the normal distribution curve. Okay, and the probability under this curve is equal to 1. Okay, equal to 1. And the mid of the middle value of this distribution curve is equal to the mean, which means we name it as mu. Okay, and we again describing another variable as standard deviation. Okay, since this is the mid value of the curve, okay, I said the area covered under this normal distribution curve is 1. Since this is the mid value, there is 0.5 for this side and 0.5 for this side. Okay, so that is normal distribution, and we have mu here. And if you go one standard deviation to this side, this area is equal to 34%. If you go another one standard deviation to this side, again it is 34%. Okay, and if we go 1.96 standard deviation to this side, we will have 47.5%. Same thing to this side, 47.5 for this side, likewise. So those are the theoretical parts that you have learned during this lesson. Okay, so I'm just recalling those memory. Okay, and that will help me to do the calculations in the next half of this session. Okay, so after that, After that, you have learned an equation. It is like this. So you tell it as the equation to find out Z score. Z score. What do you mean by Z score? What do you know about Z score? Okay. Have you heard anything about Z scores? Okay. Are you familiar with that word Z score? Can anyone tell me? Are you familiar about the word Z score? Okay, what it is? If you are familiar with Z score, what do you know about Z score? Okay, when going to universities, you need to check it. Okay, so university admissions are comes under this value Z score. So this is the exact thing. Okay, so this is how they find out that this is the base. Okay, this is the base where how they find this Z score thing in your A level exam. Okay, so that is good because you are going to learn this before your A levels. Okay, so you know now how to find out your Z score as well. Okay, after learning this. Okay, now x minus mu divided by standard deviation. Okay, now we have mu. Let's say we have x here. Okay, x here. Now what is happening is when you are using this equation, okay, you get a value for z. Okay, you get a value for z. Now with that value, you go to the z table. Okay, you are referring the z table now. So the value corresponds to this z. Okay, the value that comes from the z table corresponding to this z value is a probability. Okay, probability. Okay, and that probability is equal to the area which in between x and mu. Again, I'm telling, okay, again, I'm telling, you get a value from this equation, that is the Z value. Then you are referring the Z table, okay. By referring to the Z table, you get a value from that table, okay. That value is a probability. That probability is the probability of the area in between x and mu. Area in between x and mu. Area in between x and mu. Okay. So this is the basic theory and the one and only theory under this normal distribution part. Okay. Keep this thing in your mind and you will see when I'm like solving the equation, you will see that it will be very easy when if you are following this theory. Okay. It is very easy to find out the answers. Okay. If you were struggling, okay, to find the answers for these areas, okay, learn this theory today and it will be very easy for you to go through this part. Harid Bhute. Hari. So this is I have taught you different areas. Okay, I have taught you different areas now. Okay, about events, everything, and the normal distribution. So this is the theory part that you have learned during your during your classes. Okay, now it's the time to do some calculations and get to know that you know everything before going to the exam and you are familiar with doing papers. Okay, and facing the exam. Okay, Okay, let's see. Now, Pute, this is your syllabus. Okay, this is your syllabus. And when it comes to probability and its applications, the weightage given to this lesson is 15. Okay, 15%, which means in your exam paper, approximately 15 marks will be, or 15 points will be there from a probability lesson. Okay, so this lesson is very, very important where you can score high marks if you know this part. Okay, and when it comes to exam papers, the last question is from probability. Okay, that trend will be there, that setup will be there, and it will continue in the next exams as well. However, if it is not in the last question, don't worry, a question from probability will be there in the exam paper. Okay, so it is a definite event. Okay, the probability of having a probability question in your exam paper is 1. Okay, so that is I can say it because it is the trend that they are following during the past years, and going through the syllabus. What we can see is definitely we will have question. Okay, so let's do some questions and see whether you have uh, like got things correctly. Okay, first one. Hmm. A manufacturing company. Okay, when you are doing questions, okay, when you are doing summations and everything, okay, so okay, when you are like doing the questions, okay, read the question very carefully, read it. Okay, because like what our students have, like they are practicing is like they are reading the question but don't get anything, like they are not like marking the data that they have, and like what they are doing is reading the question repeatedly and don't get anything. Okay, uh, so when you have like when you are doing the questions, I mean when you are facing the exam, like read the question very carefully and mark the data that you have. Sometimes there are unwanted parts as well. Okay, now let's say manufacturing company of electric equipments buys electronic circuits from two suppliers X and Y. Sometimes that data is not like necessary for us. Okay, but the important part comes after that. Okay, let's see. The information about 100 circuits bought by the company during the last month is as follows. Okay, so the data that we have is here is we have 100 circuits. Okay, and we have supplier X, supplier Y, and faulty number of faulty circuits and number of good circuits. Okay, so you are required to calculate the probability that a randomly selected circuit is faulty. Okay, so what they are asking is you have 100 circuits. Okay, out of that 100 circuits, what is the probability of having a circuit, okay, which has a fault? Okay, got it? So what they are asking is put all the circuits into a one basket, okay, or one bag, okay, and take out one circuit randomly, okay, and if you take after that, what is the probability of having a fault circuit out of those circuits in the bag? That's it. Okay, that's the thing that they are asking. Okay, so let's do that. Okay. We have 100 circuits. 100 circuits. Okay. Out of 100 circuits, 6 have faults. So this is the probability of having a faulty circuit. You can simplify this and write it down as this 3 upon 50. Okay, got it. Next part. So I'm switching in between the question and this whiteboard. Okay. Next part. Uh, Calculate the probability that a randomly selected circuit is faulty given that the circuit is from company X. Okay. Now what they are asking is, okay, you have to find out the probability of the circuit which is again a faulty one. Okay. But given that the randomly selected the randomly selected circuit is from X company, that it is a conditional something, conditional probability. Condition is given where that circuit should be from company X. Company X. So you can like uh, simplify this through the equation that I have given you when I'm teaching you that conditional probability. Okay, you can use that equation, and also you can use your like logics for this one. What they're asking. Okay, before we had all the circuits in one bag, but now they are asking, okay, you can have only the circuits from company X only in that bag. Okay, before we had all the circuits, but now they have said that there is one condition: put all the circuits from the company X into that bag. Okay, okay, I put all the circuits into that bag. Now select one. Okay, now I'm going to select one. Okay, now what is the probability of having a faulty circuit, okay, out of that bag? How many faults, how many faulty circuits comes through supply X? It's 2. It's 2. And how many number of circuits supplied by this supplier? Altogether it's 45. Now we have 45 in that bag. Out of 45, we have 2 fault circuits. Okay, got it? Okay, very good. Or else you can use that equation I taught you. Okay, there is a condition. What is the condition? From company X having a faulty circuit, okay, company X, F intersection X divided by probability of X. F intersection X, they are asking how many fault circuits in so let's say like this. It's like this, no? Okay. Number of circuits from supply X and fault circuits. So the intersection is 2. Okay. Intersection is 2. The probability of X is 45. That's it. Very easy. Okay. Very easy. You can use your logics, as I said earlier, or else you can use this one equation. Okay. Both of them will give the correct answer. That's it. Okay. Happy? Okay. Next one. Next, we are moving to normal distribution part. Okay. Hariputa. Next one. The weight of a certain type of packages delivered by a logistics company is normally distributed with a mean of 540 grams and standard deviation of 48 grams. Okay. You are required to calculate the probability that a randomly selected package has weight less than 465 grams. Now, when you are reading this question, okay, it's quite difficult, right? Because when you like finish the reading part, now again you have like you don't have anything about in your memory. Again you have to read it. So I'll teach you a simple method to track all these data, okay, and write down it in a paper. Okay, again you don't need to go through the question. Okay, now let's go one by one. Okay, now this is the simple part. Okay, and the most important part. Ah, okay. Now they are saying, so when you see the normal distribution part, draw this one, normal distribution curve. And they are saying mean is 540. Now I'm writing down. Mean is 540. Okay. When you are reading the question, draw this one and mark the data. Okay. Mean is 540 and the standard deviation is 48. Okay. And they are asking the probability of less than 465. So if 540 is here, where should be 465? If 540 is here, 465 should be somewhere here. Okay, it should not be in this side. Okay, because 465 is less than 540 no. හරිද පුතේ 465 කියන්නේ 540ට වඩා අඩු value එකක්නේ. So it should be in this side. Okay. Now they are asking the probability of less than 465. So they are asking about this area. Less than 465. Okay. Now this is the part. Now everything in that question is in this picture. Okay. Do you need again to go to that question and read it? No, you don't need it. Okay. You don't want to go to the question and read it again. Okay. Only thing that you have, I mean, to do the summation part, everything that you want is in this picture. Okay. Now, what is the equation you know from this lesson? It's this one. What is x? X is 465. Mu means 540. Divide by 48. Okay. Subtract 465. 540. It's 75. So you will get minus 75. But what I say is, what I recommend is for this part, okay, for this part, for the normal distribution part only, okay, ignore minus things, minus values, ignore minus values. Okay, just write down the value only. Okay, divide by 48. 75 divided by 48 is equals to 1.56. 1.56. Now you need to go to the table and find out the probability value corresponds to 1.56. Okay, let's go to the table. Okay, let's go to the Z table. One 1.5 is here, okay, and you need to take 6 from here, okay, this value, okay, 0.4406, 0.4406, okay. Now that is the value 0.4406, okay. So Z value is 1.56, probability correspond to 1.56 is 0.4406, okay. That 0.4406 is the value of this part. I told you before. I told you the probability value that you find from the Z value equation is always equal to the area in between x and mu. This is x, this is mu. Okay. So 0.4406 is equal to this area. Now what you need to find out? You need to find out the probability over the area of this part. Okay. Now you know from mu to this side the whole area is equal 0.5. I told it you before. Okay. I told you the area under the normal distribution curve is equals to 1. Since the mid value is mu, okay, it splits into two, 0.5 to right side, 0.5 to left side. Okay. Since the whole area of this side is 0.5, if I subtract 0.4406, you will get the area or the probability of this part. Okay. 0.0594. If you write it down as a percentage, 5.94%. Okay. Got it? What's your feedback on that one? Is it easy or is it difficult? Okay. So let's do a few questions from this part. So you will get it like you will find it easy. Okay. Puta, we subtract by 0.5 because the area of this part is equal to 0.5. That's what I told you before. I told you under the normal distribution curve, the total area is equals to 1. Since the mid value is mean, it splits into two equal parts, which means to the right side we have 0.5, to the left side we have 0.5. That's it. Okay. That's what I told you. Like you have to listen very carefully. Okay. Next again we'll do few questions. Okay. So you will be very familiar with that one. Even the single medium students told me like it is very easy. This method is very easy because they also said that they were struggling. uh, we did a few questions now. I think that they are very familiar with this part. Okay. Let's do the next one. Next question. You are given the following information on how the bottles made of following three types of plastic are disposed. Okay. Calculate the probability that a randomly selected bottle is made from plastic A. Can anyone answer this question? That is easy. Okay. I need to check whether you got it or not. Can anyone answer it? No one? Okay. Very good. Very good. So first of all, what you have to do is, okay, first of all, what you have to do is, you have to find out how many bottles are there, the sum of the bottles. Okay. For that, you have to add all of these six values. 12, 5 plus 8 plus 7 plus 6 plus 12. Altogether, it's 50. Okay. 50 bottles. We have 50 bottles. Okay. Now calculate the probability that a randomly selected bottle is made from plastic A. Okay, plastic A. So for plastic A, we have 17 bottles. 17 bottles. Out of 50, out of 50, 17 bottles are there, which means the probability that a randomly selected bottle is made from plastic A is 17 upon 50. 17 upon 50. Okay, that is easy. Okay, easy, huh? Okay. Now, Bude, can you try the next one? Can you try the next one? Okay. I'll do it, but I want to know whether you got it or not. You can either use that conditional probability equation or the logic. Okay. It's okay that you can use your logic. Use some logic and find out the answer. That's okay. As I did before. If you get the answer, uh, put it in the chat box. Okay. Now, let's see. Calculate the probability that a randomly selected bottle is made from plastic B, okay, made from plastic B, given that it is disposed incorrectly. Given that, okay, what is the condition they have given? Dispose incorrectly. That is the condition. Okay, based on that condition, when you see the condition, okay, when you see the condition, now what is the condition? Incorrectly disposed. Okay, incorrectly disposed. When you see that condition, you have to take the total of this one, incorrectly disposed. 5 7, it's 12. 12 plus 12, it's 24. Out of that 24, how many bottles are made from plastic B out of that 24. Okay. So you have to put the value of the condition in the denominator. Okay. Condition, the probability of, I mean, the value of the condition in the denominator, and the next one in the top, in the numerator. Okay. How many plastic B bottle? 7. 7 out of 24. 7 out of 24. Okay. So many of you have given incorrect answer. Many of you have told me it's 7 out of 50. It's not 7 out of 24. Okay. I'll do it. I'll do it. So පුතේ මේක වෙන්නේ මෙහෙමයි. Okay. Now they say that given that disposed incorrectly. Okay. So this is the condition. This is the condition. Okay. This is the condition. Now when you see the condition, okay, when you see the condition, you first see at the numbers of that under that condition, which means the numbers comes under incorrectly disposed. Okay, incorrectly disposed. Okay, so the probability of that one is, sorry, let's say this event as A. So probability of event A is 24. Okay. Now next one. Next event is, sorry, B, plastic B. Plastic B. We have 15, yes, 15 bottles. Okay. And what is A intersection B? It is 7. A intersection B means it should be disposed incorrectly, and also it should be from plastic B. So A intersection B is 7. Okay. Now what is the condition they are telling this? The condition is, what they are telling, what they are asking is, given that disposed incorrectly, what is the probability of having a B plastic bottle? This is the condition. B intersection A divide by A. So A intersection B or B intersection is same. It's 20, sorry, 7 divide by 24. Got it? And the students who have given 17 upon 15, can you identify your mistake? And the others as well, who gave 7 out of 50, 8 out of 15. Can you identify your fault? It should not be 50 in the denominator because they have given a condition. Okay, they have given a condition. Okay, very good. Now, can you do the next question? I know that now you have the confidence to do the next question. Okay, before that, we have a normal distribution part. Let's do it and move to the next one. Okay. Okay. Now you have to do this normal distribution part with me. Okay. The weekly overtime payment of 20,000 minus staff. Okay. So keep this number like for a little bit. We'll come to that one. In a company is normally distributed. Once you see the word normal distribution, draw the normal distribution curve. Now draw it. Okay, now draw it. With a mean payment of 720. Now mark the mean 720. Okay, now mark it. And a standard deviation of 90. Now mark in the top of the normal distribution curve, write down the standard deviation symbol and equal it to 90. Okay. Now calculate the number of minus staff. Number of minus staff. They are asking not the probability. They are asking the number of minus staff. Okay. Whose weekly overtime payment is more than 7,200. Now, don't be panic. Okay. Now, I know that you will think, okay, I don't know how to find out the number of staff. I know only to find out the probability. I don't know these types of questions. Okay. Don't get panic. Okay. Okay. You know how to find out probability. Now find the probability. Okay. We can see what we can do after that. Okay. But now you know, after you draw this normal distribution curve and mark all these things, the only way that you can come out from this is finding out the probability. That's it. Okay. Only thing that you can do is put the Z equation and find it out and go to the Z table and find the probability. That's the thing that you know. Okay. So that is the only way that you can come out. So do that and we can like fix this. Okay, we can like find out what we can do after that. Okay, so muladima, don't get panic. What our students are doing is like when they see these types of questions, they say, okay, අයියෝ මේ වගේ questions මම හදලා නැහැ. ඒ හින්දා මට මේක හදන්න බෑ. That is not the thing, පුතේ. Okay, so do what you know. Okay, ඔයා දන්න දේ කරන්න. After that we can figure it out. Okay, now start doing it. Okay, start doing it. They are asking overtime payment is more than 7 to 200. Okay, now I'm also going to do that one. Okay, $720. This is 90. 7,200 should be here because it's 72. Sorry, 7,020 and 7,200 should be somewhere here. Okay, and they are asking more than 7,200 the area of this one. That's it. So if you have drawn the figure, it should be like this. Okay. Next, what you know? Finding out the Z value. Find it out. Okay. Find this. 7,200 minus 720 divide by 90. Okay. 180 divide by 90. It's 2. Now go to the Z table and find the value for 2. That's it. It should be 0.4772. Am I correct? Am I correct? Okay, again, I'll show you the table. It is simple. So this is the table. You have to find out 2 here. It's 2 here. Okay, so you can go up to 2 decimal places. Okay, since you have 2 there, okay, 2.00, no need of, there is no 2 decimal places, it should be 2.00. So you take 2 from here and 0.00 from here. So it's the value 0.4772. Okay, 4772. Okay, next It's interesting, huh? Isn't it? $720. They are finding out this one. Okay. Now 0.4772. Which area is corresponds to this one? It is this. I have told you all the probability values that you take from the Z table is equal to the area in between X value and mu. That's the theory that we have learned. Okay. That is the golden rule here. Okay. No any rules. That's it. Now you need to find out this area. How we are going to find out? The total area from here to here is equal to 0.5. If you subtract 0.4772 by 0.5, you will get the area of this one, 0.0228. This is the probability. This is the probability of this one. Now this is the probability, and they are asking the number of employees. Number of employees. The total number of employees is equal 2000, which means total area of the normal distribution curve is equal 2000. So if you want to find out the value for this area, what you have to do is multiply this one by 2000. That's it. 45.6. I'm rounding off to the nearest unit number. It's 46. Got it? We are multiplying it because, Pute, the total area is equal to 1. Okay. Here, 1 is equal to 2000 total area. If you want to find out 0.228, what you have to do? You have to multiply this one by 2000, then you will get the value. Okay, that's it. Got it? If the total area is equal to 2000, how many are there for 0.228? That's it. It's like if the value of one toothbrush is 10, what is the value of 2? Where you have to multiply it by 10. 2 into 10. That's it. The same mathematical theory, I applied it here. Okay. You will provide these tables. Okay. As I know, you can check it with your teachers. Okay. Okay. Next one. Now the next one you can do it in your own. I'll do it, but I want you to do it first. Okay. Do this one. The employees of a company are classified as management, office, and operations. The following table shows the number of employees in each category and whether they are married or not. Okay. If an employee is chosen at random, calculate the probability that the employee is married given that the employee belongs to operations category. Can you do it and give me the answer? I'll wait for you. Okay. Okay. Very good. Very good. I know that you have find out. It's easy now. Okay. Using the logic or using the equation. Okay. Whatever it is. Now it is easy for you. Okay. It's 45 upon 75. Why I am telling it? Calculate the probability that the employee is married given that the employee belongs to operations category. Given that is the condition. Okay. So when you see it, given that the operations category, so you go to operations category here, 45 plus 30, it's 75. 75 should be in the denominator. Out of that, how many employees are married? Out of that, 45 are married. 45 upon 75. That's it. Very good. Very good. Okay. Do the next one as well. Okay. Now they are asking calculate the probability that the employee is from management category of the company. So of the company. Now the company. Okay. So which means the total value. Total is 130. Out of 130, how many are from management category? It's 20. 20 out of 130. 20 out of 130. That's it. Very good. Okay. Many of you have given the correct answer. It should be 20 out of 130. Okay. Puta, they are not asking about married and unmarried, anything. Okay. Don't get confused. Okay. This is what happens to you when you like select the correct answer for the first one. Then you like going to the next question on the same ground, thinking about the same ground. That is not. The second question is a new one, a different one than the previous one. Okay. So read it very carefully. Okay. Read it very carefully. Rather than selecting a value blindly, read the question carefully and find. Puda, it's okay. It is good if you can simplify it. Okay. Better you can write down the answer after simplifying it. Okay. Just write down the first one. I mean, like this. Wait. So what you can do is you can like write it down like this. First write down this one, 75. Put a equal mark, then write down the simplified version. Okay. Now the simplified version for this one is 19 upon 15. Again you can simplify it. 3 upon 5. Okay. 3 upon 5. Write down this one. Then if they give the marks for simplified one, you will get marks. Or if they give this one, you will get even mark. I mean, you will even get the marks. Or if they like take, I mean, the both answers, again you get marks. That's it. Okay. So it's okay to secure mark. However, okay, write it down like this. Next one. Next, we have again a normal distribution one. Okay. Now, I'm reading the question. Draw the normal distribution curve and let's start working on this one. A coffee maker fills jars with coffee. The volume of a coffee jar can be modeled by normal distribution with a mean of 232 milliliters and a standard deviation of 5 milliliters. Calculate the probability that the volume of a randomly selected jar is less than 225 milliliters. Okay. Now draw it. Let's start working on that one. Okay. Now what they are saying? Normally distributed. Okay. I have drawn in. Mean is 232. Standard deviation is 5. And they are talking about numbers less than 225. This is the picture. Okay. Now, what is the equation you know? This is the equation. 225 minus 232 minus, sorry, divided by 5. 225 minus 232, it's minus 7. I have told you, okay, ignore minus marks for this lesson only, okay, this part only, okay. Don't ignore minus marks everywhere. And 5, okay, divide by 5. Now 7 divide by 5, it's 1.4. 1.4. Now go to your Z table and find the value. 1.4. One 1.4. It's 4 0.4192. 0.4192. Okay. Give me a second. Okay. 0.4192. 232. 225. Okay. 0.4192. So that area is corresponds to this one. That's what I told you. Okay. But they're asking about this area. So since you know this total area is 0.5, what you can do is subtract 4192. You get 0.0808. 8.08%. Okay. Got it? Okay. Very easy, huh? Okay. Next, let's move to the next question. Okay. Next question. Can you give it a try? Okay. The same thing, huh? But you can use that equation, the conditional probability equation here. Give it a try. Let's see. How was it? Quite difficult, huh? Okay. Don't think much. Let's do. The probability that a student passes a written exam is half, 1 upon 2. Okay. So we have two events now here. The probability of passing the written exam and the probability of passing the practical exam. Okay. And they have given the intersection of those two as well. Okay. Intersection of those two. Okay. Uh, let's see. Okay. Now they have given, we have two events. Event A, pass written exam. Event B, pass practical exam. Okay. So the probability of event A is half. Probability of event B is 1 upon 3. And the intersection, probability of intersection is 1 upon 4. Okay. Now they are asking, what they are asking? Passing the written exam given that passing the practical exam. So what is the condition? They have, I mean, the student should pass the practical exam first. Okay, that's it. So probability of, this is the condition, A intersection B divided by B. That's it. 1 upon 4 divided by 1 upon 3. 1 upon 4 divide by 1 upon 3, which means you can write it down like this. You can convert this division mark into multiplication, but you have to take the reciprocal of this one upside down. 3 divided by 1. So the final answer is 3 divided by 4. That's it. Easy? Easy? So what I want to give you is, okay, sometimes there can be questions like this. Okay, now this question is quite different than the previous three. Okay, quite different than the previous three. What our students think is, okay, now I'm okay to do the questions like the previous ones, but this is something different than the previous ones. So I can't solve this. It's not like that. Okay. That's what I told you. Rather than reading the question again and again, write down the data that you have. Okay. Write down the data. That's what I have done here. Here. I have done that part. Okay. So when I write and when I'm writing down it, I can see a way to solve this one. Okay. I can see a way to solve that one. Okay. So that is the importance of like marking down the data, okay, and visualizing them, then you can solve it very easily rather than reading the question. Okay, අපේ ළමයි කරන්නේ so reading and reading and reading and thinking, okay, I can't understand, I'm fed up, I can't do that. That's it. But don't do that. Give it a try. Okay, at least write down this one, at least write down this equation. Okay, sometimes, okay, at least the the examiner will see that, okay, okay, you have even tried, okay, you have written some steps, okay. So if they are giving, the marks for those steps, you may like have 1 or 2 marks even. Okay, don't like leave the paper blank. Okay, just try, then you can find a way to come out. Okay, so give it a try. Next one, the final part. Okay, Pute. Now the last part, uh, the normal distribution part. Can you start solving it? I know now you are very familiar with normal distribution now. Okay, I know that you can do it very very well. Can you start doing it? I will also do that. I'll give you a few seconds, few minutes to start it. Then I'll do it. Okay. They are saying the mean as 170 and the standard deviation is 5 and the probability greater than 180. Okay. What you can do? Write down this one. Okay. 180 minus 170 divide by 5. Okay. 10 divided by 5, it's 2. So when you find out the value from the Z table, it should be 0.4772. 4772. Okay. 4772. Okay. 4772 is the area of this part. But you need to find out this area. How you can find it? 0.5 minus 0.4772. Okay. 0.0228. 2.28%. Is it? Okay. How was it? Let me know if you have if you are struggling under this part. Okay. And now is it easy? Is it easy to solve this normal distribution part? Okay. So don't think about, other things. If you are struggling, but you have uh, doing it previously, okay, you can use this theory, okay, one simple theory for the whole lesson, okay, for the whole lesson. This is the simple theory that you have, okay. you can do, read the question very carefully and draw this one. Sometimes they might ask this area, okay? It can be changed. Sometimes they might ask this about this area. Okay. It's up to you to like it should come from you. It's how you draw the picture. It's how you draw the mark, I mean the area that you want. Okay. And find out the answer. Sometimes they might ask, okay, what is the value in between, what is the probability in between the values of 170 and 180? If they ask like that, the answer should be this one. Okay. So answer should be 0.4472, 4772. Okay. That can be changed. But the theory is this one. Okay. Theory is this one. So if they ask, I'll teach you one again. If they ask less than 180, less than 180. Sorry. Wait. If they ask less than 180, it should be this, whole this. Now you know 0.4772 is this part, this area, it's 0.5, right? So all together. Okay. Simple. It's how you draw the picture and mark the area that they are asking. If you mark the area, you will see what you need to find. That's what I am telling. Draw the picture, okay, and mark those areas correctly. Then you will like okay, what part you have to find out. Then it's something like what you have to do is like you need to use the things that you know. What you know is that area after area in this side, I mean in the left side after mean is it's equal 0.5. Those are things that you know. It's up to you to like use those things and find out the answer. That's it. But the simple theory is that one. Okay. Is the theory that I told you. Okay. It can be changed. I mean, theory is not changing, but the way you using that one is can be changed with the question. Okay. Is it easy? Okay. Very good. Okay. Now I think you have a good idea about the probability lesson. Okay. And about normal distribution as well. And I have done 4 question papers. And in the AAT website, you have many more past papers. So go through the past papers and do them before your exam. So you will have a good practice plus the time management. Okay. So do those things and I mean take more experience about solving these things and face the exams. Don't be afraid. Okay. Don't get panic. You can pass it and you can easily go through it. Okay. So I hope that everyone will score A marks, A passes for this subject. So congratulations all of you, and you can find this video in AAT official YouTube channel as well. So you can watch it again and again before the exam. So okay then. Good night and congratulations on your exams. Thank you.